Welcome back to another video on the Polymath student channel. I am Dron, and I will be covering the second part of kinematics today. So today I will be covering gravity and motion in two dimension. So I'm specifically going to be covering gravity, how it relates to kinematics. So the thing that you need to know is this constant, small g, little g, and it's essentially the acceleration caused by gravity or acceleration due to gravity. And the magnitude of this constant, meaning that it's like a number, it doesn't ever change, is 9.81 meters per second squared, or 10, depending on if your teacher decides to simplify it. Sometimes they'll say 10, sometimes they'll say 9.81. Just look at whatever they specify. Now, this is actually a vector quantity because gravity, if you know, it will always point downwards or towards the center of the Earth. So if I throw something upwards, acceleration due to gravity is what brings it down. So if we put it as a vector, by using this arrow is basically how you notate vectors. You put the arrow above the thing, above whatever term it is, and then this would become negative 9.81 meters per second squared. So, why is this important? Well, it is helpful with dealing with the y-axis or the vertical motion. So, if I give you an example, and let's say that this is a cliff, okay? And I am dropping a ball off this cliff. All right? Then, and we want to see how far it falls. And let's say that this happens in 5 seconds, okay? So t will be equal to 5. Okay. And we're solving for change in y. Let's just assume that this is 0. Okay. And since we're going to be shooting down as negative and up as positive. Okay. So if I want to solve this, I can use the fact that we know that the ball is being dropped, meaning that the initial velocity is 0. Whenever something is said like dropped or released from a height, unless it says there's a velocity associated with it, you can always assume the vertical velocity is 0 because if you're something on your hand and then you simply drop it, it doesn't you're not like boosting it forward. You're simply releasing it from rest into motion. So since we have the time, we are solving for a change in y, and we have the initial velocity of 0, we can use this formula, change in y, which is different from our change in x. I mean, it's the same formula, but we just changed it because we're dealing with the vertical context here, into VOT plus 1 half AT squared. Now, we know that VOT, this term will be 0 because initial velocity is 0. And for the sake of making this YF simpler, I'm going to make this like this. So, okay. And we know that y0 is 0 simply because I set it as that. The question we usually specify. So it would be yf is equal to 1 half AT squared. But we also need to note that this change in y, since we're going lower than the original height, then this final position is essentially going to be negative. So let's just, for the sake of this, we're going to write this as, if we would go back into change in y notation, you write this as negative change in y is equal to, or rather we can simply leave it as this actually. Okay? And then we substitute what we do know. So we know that we have time is 5, and our acceleration due to gravity is 9.81. But we'll use 10 for convenience sake this time. And we know this because it is a ball. Vertically, it's going down towards the Earth with that acceleration, and there's no other force acting on it. So from that, we can determine that the acceleration is simply caused by gravity. So if we want to write this as negative 10, because we are going downwards and we're using the vector form here, and then 5 squared is 25. So if we solve this out, we will get, let's see, so we'll get negative 5 by multiplying these two times 25. So then you would get negative 125 meters. Okay? So we know that we are going down by negative 125 meters. So this entire cliff is 125 meters high if you were solving for that. Okay? Now, just in case you think went so fast, I will go over everything we did. So I already told you that g, this constant, is acceleration due to gravity. And it is a constant, and it comes about when there's no other force acting on an object, and it's falling downwards to the earth. So it has this acceleration. Oops. And I said that our time is 5 seconds to hit the bottom. And since it was dropped from hand and it was released, it has an initial velocity of 0, and we're solving for change in y. So basically using that change in x equals to v o t plus 1 half at squared, we turned it into our y direction one, and then we made it into this sort of thing where we got rid of this vot and we got rid of this initial position, and then we went back to change in y. So from here we found that the change in y was negative 125 meters. So gravity is a pretty simple concept. It's just if you have an object and it's going vertically, or even if it's like in the air, like even if we both have vertical and horizontal motion and I threw it like this, then it's still going to be going down at the same consistent acceleration. And the important thing to note is that this will happen no matter what the properties or like what the mass of the object is. So oftentimes, you'll think that like something lighter will take more time to fall than something heavy. And while this is true in most practical scenarios, because we're not in a vacuum and things like air resistance act differently on objects of different mass, in a vacuum, the objects will actually hit the floor at the same time. So if you go to the moon, right, where there's no air or anything, and you drop a brick and a feather, both of them will hit the surface at the exact same time. And this was verified by Galileo by, I think, sliding something on ice or like on a ramp to where he found that no matter the mass, the objects would hit the bottom of the ramp at the same time, which essentially replicates that kind of frictionless, air resistanceless property that is needed to prove that gravity is constant. So, any other sort of motion besides the vertical motion will not affect if how long something takes to hit the ground. So whether I have an object that's 10 kilograms or 5 kilograms, or is moving horizontally at 10 meters per second or 5 meters per second horizontally, that will not affect how long it takes to hit the ground. There's a Mythbusters video on where they actually test out if you shoot a bullet or if you drop a bullet, if they both hit the ground at the same time, and they found that they basically did with reasonable margin of error, which is like a couple of milliseconds. But yeah, will both hit the ground at the same time. What we're going to be covering is going to be motion in 2 dimensions. So essentially, this is the idea that an object, as you can tell, like in real life, you can move anything in both horizontally and vertically. You're not restricted to just moving it in 1 dimension. So similarly, just for right now, we're going to be dealing with 2 dimensions. So essentially, means that we're going to move something in X and we're moving something in Y. So what we need to know before we get to that though is vectors as a visual component. I explained vectors previously through just like symbology and the definition, but we need to get into the actual visual aspects of vectors. So basically a vector is just an arrow with some direction and some magnitude. So let's just say that this is 5 meters per second, okay, in the x direction, or this is 4 meters per second in the y direction. Now, if I wanted to add up these two vectors, I could do vector addition. So how this works is essentially use this method called the head to tail method. So the head of the vector goes to the tail of the vector. So it would be 5 meters per second and then 4 meters per second like this. Forgive how the arrow should be straight. I should make them straighter. Hold on. Okay, well, they're not perfectly straight, but you get the message. And then from here, you basically make a connecting vector like this. Okay, so you can kind of see how this follows the Pythagorean method of how you take these two sides and then there's a right angle here, and then you have this vector, which will basically be your total distance crossed. Okay, so if I want to say, let's not make these meters per second, or actually it's fine, because vectors can deal with meters per second as well. So if I'm going 5 meters per second to the right and 4 meters per second upwards, then we want to see the rate at which I'm traveling over some distance, okay? So by using the Pythagorean method, which is basically a squared plus b squared equals c squared, I'm sure you know this. And then we insert, let's just say 5 is a, and then 4 is b, and then c squared. And then we square it off, so we get 25 plus 16 squared equals to c. And then from here, you would get the square root of 41, which you can't really simplify anymore. So we know that we are traveling at this meters per second, square root of 41 meters per second. So that is essentially motion in 2 dimensions. Now, it's important to note that we can also do this with any sort of vector. So we can do this with like displacement. We can do this with accelerations as well. And the best way to solve problems that deal with motion in 2 dimensions is to split them up into both x and y components. That's how my teacher taught me to do it a while back. So basically what you do is if you want to deal with the x component first, and then you deal with the y component. And usually when you're problem solving, to find a relation between those two, the time it takes to do both will usually be the same. So you basically solve for time in one direction, and then you can substitute it into another. It'll make more sense when I explain it in the next video, which will be over problem solving. But for now, just keep that in mind, that time is basically the thing that connects both x and y together. So, how does this relate to gravity? Well, it relates in something called free fall, or basically when the only force acting on an object is gravity. So if I go back to this cliff example, make this cliff bigger. And say I, instead of just dropping this ball, I throw this ball. So this ball is going with, let's say, 1 meter per second horizontally. And it doesn't have a vertical velocity because I didn't state that it had a vertical velocity. And usually in these problems, there isn't going to be one unless they say it. You know, you're just kind of throwing it horizontally straight up. So the track that this ball will follow, because of gravity, will be parabolic. And if you know about how like quadratic equations look, and you look back at the change in y equation, which is basically a quadratic, then you can understand why we get this parabolic motion. But in this situation of free fall, like I said, the only force acting on it is gravity. So this 1 meters per second acting horizontally, this velocity will not change because acceleration requires some other force acting on it. But in the horizontal direction, there's no force acting on it. So whether I'm down here or I'm down here, the horizontal component of velocity is 1 meter per second. This is not true about the total velocity, however, because total velocity would be the sum of the x direction vector and the y direction vector. So that's important to note. So since I'm moving in both an x direction and a y direction, this is essentially 2 dimensional motion. Now say that I want to solve for the velocity right before it hits the floor, okay? So essentially this would be the vector sum of both the x and y components of velocity. And let's say that since we know that the acceleration is gravity, and let's say that it gets here in about 4 seconds, okay? So t equals 4. Now, if I want to solve for the final velocity, or at least the velocity right before it hits the ground, here's how you would go about doing it. So, since we're doing x squared plus y squared equals 2vf, okay? And since we already know what x squared is, we can basically substitute 1 here to get this, okay? Now we need to solve for the y velocity. So, what do we know in terms of y? We know the acceleration and we know the time. And we actually know the initial velocity as well, because if you remember that since it's only following a horizontal velocity initially, it has no vertical velocity. So now that we have VO, the time and acceleration, we can use the formula VF equals to VO plus AT, since we have everything here and we can solve for final velocity. So now, if VO is going to be 0, so this will cancel out. So we get VF equals to A times time. And then if we substitute, we get negative G as the acceleration times time, which is 4. So this will be about negative 40 meters per second. Okay? So this is our velocity in the y direction when we get to this point. Now let's put it back into our original equation. So we get 1 plus 40 squared, which is 1600. And then when we solve for this, we always just get the square root of 1601, which I'm not sure exactly where that range is between. It would have to be between 40 and probably the square root of like 41-ish. So it'll be between that number. So your final velocity right before you hit the ground will be this square root of 1601. Yeah, 1601. Okay. So now that we've solved for essentially a free fall problem using two-dimensional vectors, we know how gravity relates to kinematics and how we can solve in two directions. So that is going to be it for this video. I am going to do more problem solving for the next video, and I think it'll make a lot more sense when I do some problems because a lot of the stuff is quite simple to understand initially. But once you do problems, it becomes difficult. But problems are also the best way to learn and to learn physics, basically. It's better than just studying theory. You have to apply it. As you know, theory alone can only get you so far. So that will be it for this video. I've covered gravity and two-dimensional motion and how those two correlate to each other. So in the next video, I will be covering some problems that further, you know, give depth into kinematics. So if you enjoyed this video, make sure to like and subscribe. I appreciate it a lot. I got a lot of support on the last video, and it was very helpful. It motivated me to keep on going. So if you want to see more videos like this and more frequently, please like and subscribe, and I really appreciate it. Other than that, bye.